Okay, here we have the Nissan, or the Japanese automatic transmission company. Nissan designates this transmission the RE5R05A. And here we see the lower and upper valve body assemblies. Here, approximately 1/2 of the valves from the lower valve body assembly are carefully laid out. The valve bodies are carefully disassembled. We want to make very careful that we use both plastic and wood to actually disassemble the valve body. We certainly don't want to use a metal pick and scratch the aluminum anodized valves. Yes, the majority of valves here are aluminum, and they're have an oxide coating, and this improves their wear characteristics and allows them to last a long time. One thing that's very helpful if a valve is sticking or trying to move in a scored or worn bore, oftentimes you see the anodized coating disturbed. So obviously if the valve looks perfect, chances are it is. If it's moving smoothly back and forth in the bore, there's nothing wrong. Here with this transmission, the actual filter is a filter screen. It's not a Dacron cloth filter, it's actually a filter screen. So you don't have quite the protection here with this valve body as you do with some of the other manufacturers like ZF and Mercedes. But this valve body is in pretty good shape. We're going through it, cleaning it very carefully. It's going to get a new set of solenoids. That's oftentimes a wear-out mechanism. One problem with this transmission is the transmission cooler. The heat exchanger from engine coolant to transmission fluid often fails, and here we get a little bit of antifreeze in the transmission fluid, and that can play havoc with, of course, the rubber seals and the friction material on the clutches. This doesn't seem to be the case, though, with this transmission. This is out of a 2006 Nissan, or I should say Infiniti. And this is actually the M35X. This is the all-wheel drive V6 performance car. This is the M35X. So this should be a good rebuild. Carefully going through the valve body, freshening up the solenoids, and we're ready to move to the next phase. Now, one thing on this is sometimes it's necessary to remove the paper gasket. And this paper gasket is in excellent condition, so I'm not going to try and remove it. If it's necessary to remove this, oftentimes what we're doing is we use a trisodium phosphate and water. Actually, what it is it's the Aluma wash from the washing machine for the transmission cases. And we just simply either put this in the washing machine or just lower it down in a pan of boiling water with a little bit of the Aluma wash cleaner. And what happens is that gasket just lifts right off. You want to be careful about scraping it off, because obviously I would scratch the separator plate unnecessarily. And some shops actually leave the gaskets off. They just carefully clean the plate and then put it back without a gasket. And hey, as long as we get a reasonable seal, I don't think there'll be any problem. Here we can clearly see the ports there for the check balls. And of course I have some very nice diagrams to show me where the check balls go. And of course the configuration of all the valves. So there won't be any confusion as it goes back together. Now here we are looking at the lower valve body of the Nissan or Infiniti RE5R05A automatic transmission. Now this particular unit came from a Nissan Infiniti, and this was the M35X, and this is a 2006 model year. Now it just so happens this is the later version, or what JATCO, Japanese Automatic Transmission Company, calls the Design 3, third design, or I guess I wouldn't use the word Type 3, but Design 3. So this is the later style valve body. And here what we've done is we have removed all the valves from the aluminum channel, and carefully inspected each one. Now, many auto manufacturers, transmission manufacturers, are favoring these aluminum valves that are actually anodized. So what we see here is a hard oxide coating there on the aluminum, considerably harder than the aluminum that makes up the valve, and of course the aluminum channel plate itself, the actual lower valve body. Now, there's nothing wrong with this valve body. All valves are clean and moving very smoothly. If the valve is sticking in the bore, one thing that it can do is it will actually disrupt the oxide coating. So it will be very clear that this valve was seizing or sticking in the bore. Now, many of these valves have a rather stout spring. What the problem is when a valve has a very light spring, so it depends on strictly hydraulic pressure to shuttle it back and forth, it may be more prone to sticking. Now, this particular transmission isn't known for having a problem with the valve sticking in the valve body. However, it is known for having problems with the actual shift solenoids, which we'll take a look at in just a moment. Now, this particular unit, Jatco likes the screen. This is actually the filter screen, not a cloth filter, but a filter screen. And this is the actual original one. This is from 2006, and I washed it out carefully in the solvent tank, but there really wasn't a lot of material in it. Now, the brand new one doesn't cost very much. Here's a brand new one. And, it's kind of a toss-up. Are you going to clean it or replace it? If it was really packed with material, it may be hard to get it out between the lower section and the screen, so a few dollars and go ahead and get a fresh one. And usually it's kind of considered part of a rebuild. Now, what we're going to be doing is go ahead and installing each one of these valves back in the valve body, but let's go ahead and discuss what they are. And when working on this valve body, or any valve body, you want to be careful that you don't actually scratch the valve. So as you're working it out of the bore, it's a good idea to use a plastic O-ring pick, and I don't have to worry about scratching the aluminum. Oftentimes just simply a wooden tool. This is just simply dowel stock made out of wood. Now, here I have a set of tweezers. You want to be real careful about this. It would be for grabbing a valve here at the end and kind of coaxing it out of the bore. Now, one of the problems with the way that many of these valves are retained, and they can have a very stout spring, is I actually have this metal retainer. Now, what happens is if we look very, very closely, this metal retainer can actually pick up the aluminum here in the valve body. So after I remove the retainer, the valve doesn't want to slip past it easily, or on a passage where I have aluminum plug, the plug doesn't want to come out. And what is the solution? Well, what you want to do is take a type of deburring tool. Here I'm just simply using a razor knife, and very, very carefully just simply cut away that edge. Be careful not to excessively scratch the bore. Now remember, the valve's not riding in this section, so I wouldn't have to worry about the valve catching. But here I just want to be able to properly disassemble the valve body. And here we're going to go ahead and just take a look at this particular valve right here. And as I go ahead and slide it in, apparently I cleaned it up pretty well because it's not catching. But initially it did. All right, let's go ahead and just quickly talk about each individual valve and their function. And here we'll go ahead and take a look at our first one here. And this one is the torque converter regulator valve. Here's its spring, rather stout, and there we see its retainer. Now, what is the torque converter regulator valve doing? It adjusts the torque converter operating pressure to the optimum pressure for the operating conditions. And there, right next to it, we see the line pressure regulator valve. Now this is a critical valve, and oftentimes, as if you purchase a shift kit, they'll oftentimes give you a little stouter spring to raise line pressure. Now the way this particular system works, the line pressure regulator solenoid is actually fighting the spring, and the solenoid is normally vented. So in the case of an electrical failure, I have obviously park, reverse, neutral, and a forward gear, but I'm going to operate at full line pressure. There'll be nothing to try to reduce line pressure. So the spring, tension of the spring, is going to define full line pressure. There is another little assist, and that is, if you look carefully, this spring bears against this valve that slips down inside this barrel. And this port right here is connected to the reverse brake circuit. So what happens when the manual valve is positioned to charge the reverse passage, it will help boost line pressure slightly, adding to the force of the spring. And oftentimes, when I'm actually reversing the direction of rotation, reversing the direction of torque, there through an automatic transmission, it's necessary to raise the line pressure to keep the elements from slipping. Okay, let's go to the next one. Now the next valve we want to go ahead and take a look at is going to be the front brake band pressure control valve. Now many of these valves are pressure control valves for different shift elements, and this one, of course, the front brake band pressure control valve. Now this front brake band is going to be applied in first, second, third, and fifth gears. And when the front brake band is applied, it adjusts the apply pressure to the optimum pressure for the operating conditions and supplies it to the front brake band. Now the front brake band is actually actuated by a servo piston there in the case. And of course, as part of the overhaul, we remove that, clean it, and replace the rubber D-type or O-ring type seals. All right, now we move to the accumulator pressure control valve. Now it's going to adjust accumulator pressure acting on the accumulator piston and low coast reducing valve to the optimum pressure for the operating conditions. Now what happens is I do have a couple of accumulator pistons, and here we see the accumulator piston. And now this one actually is for the neutral to reverse, or as I go from park to reverse. This is going to help soften the apply there of the corresponding clutch for going in reverse. And this is actually going to be a brake type clutch. And give a soft engagement, initial engagement. That's what their goal is. All right, the next thing is, we said the accumulator pressure control valve. Now, these two valves, they look absolutely identical, but if you look carefully, their stems are a little bit different size, and the springs are a little different length and tension, so you want to be careful not to get these swapped. It looks like it could easily be done. Now what these are, they're called pilot valve A and pilot valve B, and what these do is they regulate line pressure to a lower pressure that's actually used by the shift solenoid valves. So pilot valve A, this first one with the white spring and the white color, it's going to adjust line pressure to control pilot pressure required for the line pressure control solenoid feed. We talked about that here for our line pressure regulator valve. And it's going to control the lockup solenoid feed and the low coast brake solenoid feed. So this is going to be supplying this I should say what they're calling pilot pressure, or lower than line pressure, and it's regulated within a narrow window. So regardless of the change in line pressure, our pilot pressure is going to be relatively constant. And then next to it, it looks identical, serves a very similar function. This is pilot valve B. It adjusts line pressure to a constant pilot pressure required for the direct solenoid feed, front brake solenoid feed, input clutch solenoid feed, and our high-low reverse solenoid feed for shift control. All right, now we're moving to the low closed brake shift valve, switch valve. Now during engine braking conditions, it supplies line pressure to the low coast brake clutch reducing valve. Now, one thing that's interesting when you look at this, and here we see the low coast brake clutch reducing valve, is that it's possible for this transmission to go through its whole life and never use that low coast brake. And the reason why this would only be functional if you actually pull the transmission down into manual low and use that low coast clutch to prevent the low sprag clutch, or what they call the forward sprag clutch, from overrunning. So it's very possible these aren't really going to do much there in the life of the car. As I looked at the low coast brake clutch plates, they looked like they had never been applied. They look brand new. So here we see the low coast brake clutch switch valve, and right next to it we see the low coast brake. When the clutch is applied, it adjusts the apply pressure to the optimum pressure for the operating conditions and supplies it to the low coast brake clutch. Now the idea is I don't want it to apply too aggressively, because this is going to be a downshift. I'm trying to use engine braking. I've pulled the transmission down into manual low, so I don't want a severe jerk. So what it's going to do is it's going to allow me to apply this clutch at a considerably reduced pressure and some slippage before it finally holds to prevent a severe jerk. And then right next to it, this is the, like we said, the third generation valve body, and it only has one accumulator piston for a neutral reverse. And that's what this is. This is this neutral reverse accumulator piston. Earlier units would have two. This only has one. All right. Now, as you're rebuilding a valve body, of course, I'm cleaning the valve body carefully with solvent, going ahead and rinse it thoroughly, blow it out with shop air, make sure it's real clean, no metal, no bird debris. I don't see any scoring on any of the valves, so this looks like this valve body is in excellent condition. There's really no problem. So let's go ahead and move to the other side. And here we're seeing the remaining valves. And we'll go ahead and take a look at up here at the top. Here we see the reverse clutch pressure control valve. There you see its bushing, its spring, and the two sections. Now this reverse brake pressure control valve, it adjusts supply pressure to the optimum pressure for the operating conditions and applies it to reverse clutch brake during a neutral reverse switch. Now you'll notice as we look at the hydraulic schematic that JATCO, Japanese Automatic Transmission Company, went through a lot of trouble to give the customer a good feel as he goes from park to reverse, neutral to reverse, and of course neutral to drive. He doesn't want a severe jerk. As much as possible, an imperceptible shift. Now let's go ahead and move to the next, and here we see the direct clutch piston switching valve. Now this operates in 4th and 5th gear to release the large cavity of the direct clutch. This valve is controlled by the input clutch feed. Now the direct clutch actually has two cavities. It has a large and a smaller cavity. Now the reason for this is that under certain conditions I want a degree of slip. I don't want an aggressive grab of this clutch as I apply it. So initially what JATCO had done was to have two sections to that to the clutch piston. There's actually a small cavity and a large cavity. However, what's going to happen on some of the later transmissions, especially the high performance models, you'll notice that no, the sealing ring that separates the two sections is missing, and you're scratching your head thinking, what's going on here? And this is a transmission that's been torn down and having never been rebuilt before. It was designed that way. What they're doing is they're just simply allowing the shift solenoids and the electronics and controlling line pressure and the shift solenoid to fully define the force and the feel of the clutch. So you you may find that this valve is here in the valve body, but it's not serving that purpose anymore, especially if that sealing ring is going to be missing there on the hub that the direct clutch is going to be fed from. You'll see there are normally 3, and if you see 2 only and the one in the middle is missing, you know what they are up to. All right, now we move to the next one here, and here we see the direct clutch pressure control valve, the input clutch pressure control valve, the high and low reverse clutch pressure control valve. Boy, these guys look exactly the same, don't they? Be very careful you don't mix them up, and probably, if you'll notice, it probably wouldn't hurt to mix them up. But what are they all doing? Well, these control valves, when the input clutch is applied in 4th and 5th gears, it adjusts the apply pressure to the optimum pressure for the operating conditions and supplies it to the input clutch. And then as I look at the next one, for the high and low reverse clutch, it's going to be applied in 1st, 3rd, 4th, and 5th gears. The same verbiage. It adjusts the apply pressure to the optimum pressure for the operating conditions and supplies it to the high and low reverse clutch. So here we see the direct clutch pressure control valve, the input clutch pressure control valve, the high and low reverse clutch pressure control valve. They're all really serving a very similar function and controlled in a very similar way. And remember, the apply of the clutch is going to be controlled by a corresponding solenoid. And the solenoid will be pulse width modulated. Sometimes you use the term linear solenoid because I can determine the amount of apply or the pressure buildup there working against the valve. Now, on this unit, 3 of the solenoids are normally vented and 3 of them are normally closed. And what Jatco has done, they've designed the system so if there's no power whatsoever, you're going to be able to drive the vehicle. I have park, I have reverse, I have neutral, and I'll have a forward gear. Now, I'll be operating at maximum line pressure, and obviously I won't be shifting, but at least I'll be able to safely move the car so that I can get it to the repair shop or to the dealer. All right, now the next thing we're going to take a look at is the torque converter clutch control valve. And here on this unit, we're going to have a multiple plate type torque converter clutch. There within the torque converter, there's actually a clutch pack with a series of plates and steels. Looks very much like one of the normal clutch packs there within the automatic transmission. And what this is allowing Jatco to do is to control the feel and apply of the torque converter clutch and actually let it slip under certain conditions to soften the apply feel so it's imperceptible to the operator of the vehicle. And as we look at it, we see, of course, a bushing. We see the valve, we see the spring, and then here we see the control valve itself. So here that I can modulate the force against the control valve either via the spring or via the bushing and the small valve. And then last, we're taking a look at the torque converter clutch lubrication switch valve. Now what this does is this simply operates during the lockup process, that is the torque converter lockup, to switch the converter cooling and lubrication system oil path to the cooler. So what's happening, instead of fluid there flowing through the torque converter, it's going to bypass it when the torque converter is locked up and flow directly to the transmission cooler. And then on to the lubrication system, or bypass the cooler and move to the lubrication system. Now here on our Jatco unit, this is actually the manual valve. And this is actually controlled by a manual linkage, and this is going to be selecting whether it's park, reverse, neutral, or a forward drive gear. And as we look at the end of the valve body here, I see actually the line pressure relief valve. It's simply a check valve and a spring. If for any reason there's a failure and the engine revs to high RPM and line pressure climbs above a specified value, this ball simply unseats to protect the transmission. And this is the cooler bypass. If for any reason the transmission oil cooler is blocked, then what happens is that this valve will unseat and allow the oil returning from the torque converter to bypass the cooler and just return to the lubrication circuit or the sump of the automatic transmission. Now, as we take a look at our automatic transmission, one critical aspect here is the location and function of certain check valves and check balls. Now, on this particular unit, we have 5 filter screens. Now, on these filter screens, they want the cup facing upwards towards the valve, towards the separator plate. And here we see the screen. Now this one's nice and clean, but of course they gave me brand new ones, and I will use the brand new ones. And then I have 2 check balls. Now, this is actually a torque converter drain back check ball. And there we go. And then here is a reverse brake check ball and spring. Now as we take a look at the hydraulic schematic, this is part of kind of an exotic network to control the apply of the reverse brake, to control the engagement field as I go from park to reverse, neutral to reverse, so I don't get a sudden jolt or jerk. All right, and here we see the upper section of the valve body, and this is where the transmission control module is going to be mounted. A transmission control module is going to have a series of pressure switches which are going to measure pressures at specific circuits. This is a feedback there to the transmission control module. And I have 3 check balls, and let's go ahead and take a look at their location. Now, one thing that's always good to have a good documentation to let you know what the check ball is for and where it goes. All right, so that first one, that's for the forward brake clutch, and the next one is the low coast brake clutch, and here we see the last one is the reverse brake clutch. And here we see the kind of a sub valve body. This is for the manual valve, and here it has its own check valve and spring, and this is actually for the forward brake. Okay, here we see the transmission control module. Now, this one, of course, you see the JATCO, Japanese Automatic Transmission Company, and this is a Bosch unit. Now, there are several vendors that make these transmission control modules for JATCO. This one happens to be the Bosch model. This is actually a later, this, like I said, a 3rd generation or Type 3 unit, or 3rd design unit, I think as they like to use the verbiage. Here we see the connectors for the different shift solenoids. Now I have 2 different types of shift solenoid. This one is they're calling as normally vented. So here we see the normally vented solenoid, and this one is the normally applied solenoid right here. Now as I take an air gun and I go ahead and check these, sure enough, I'll notice that if I apply shop air gently, very gently, I notice that this one is open all the time, and it does have a supposed 29 thousandths orifice. The orifice is always exposed to this port, but when this solenoid is de-energized, it actually vents it. So I can actually feel the air venting. This one is normally applied. In other words, when de-energized, the vent port is sealed off. Now, as I apply pressure, I sure can feel the air coming through the 29 thousandths orifice, but it's sealed off from venting the fluid in the passage to the sump. So here we see what we call normally vented, and here we see normally closed or normally applied. They say NA. Now, there's one, and these, by the way, are pulse width modulated, linear type solenoids, so they'll actually vary the degree with which they either vent or close off the port. Now, this one, this is just simply an on-off solenoid. It's normally closed and simply on-off. And this is the low close brake clutch solenoid. And here we go. Here the solenoid is just simply going to slip into the corresponding connector here of our transmission control module. A little bit of a snug fit. I actually numbered these solenoids, but as you can see, the normally vented have the same part number, and the normally applied, they have a different part number. Want to be careful, the normally applied and the normally vented, they can slip onto the same electrical connector. Here we go. And this is actually how these would be configured. A little bit stiff there coming off, and that's good. I want a good connection, no problem. Here I have my 7 solenoids, and they're all here in their corresponding position. Now, if this has been contaminated with antifreeze, these O-rings will swell to the point where you'll have to just about destroy the solenoid to get it out of the valve body. In that case, I would go ahead and reject the solenoid. Also, interestingly enough, the actual conductors, tin copper conductors that are coming up to the solenoid connectors, they can be a little fragile, and sometimes they'll actually break. And it is possible to disassemble the TCM and actually repair those. But we don't seem to have a problem here. I'll usually always have a corresponding fault code for an open circuit. For a solenoid, when you check the solenoid with your ohm meter, you find, hey, it's right within spec, but hey, the TCM is incapable of controlling it. Now these are actually the pressure switches, diaphragm style switch. Several other manufacturers use similar types, and there's actually a repair kit for these. These don't seem to be a problem with this model. One is they face down instead of up, so they're not prone to catching material. Now, oftentimes when you're rebuilding this transmission, you'll be replacing the solenoids, and they have both new and remanufactured solenoids. And what is a remanufactured solenoid? It's a used solenoid that's carefully put in a test fixture and evaluated for its performance. And if it passes all criteria, they put it in a plastic bag and sell it as a remanufactured solenoid. One thing you want to be sensitive to is there are a couple of different low coast brake, normally closed solenoids with different ohmic values that you want to be sensitive to. But otherwise, we've had good luck with the remanufactured solenoid kits, and they're pretty reasonably priced.